Hello, my phenomenal viewers, and welcome on to this episode. So, on today's episode, we are going to be answering this question, which is under thermodynamics. And the question reads: a domestic kettle rated 250 volts and 2.3 kilowatts caused the temperature of 2.5 kilograms of water to increase by 50 degrees Celsius. For how long was the heating done? And we've been given the specific heat capacity of water to be 4,190 joules per kilogram per Kelvin. So as we can see, the question is under thermodynamics, and I would like you to go grab a book and a pen and join me as I solve this question. So solution. Now coming back to the question, we've been given the rating of this kettle, and the rating of this kettle is for the voltage is 250 volts. Then the power of this kettle is 2.3 kilowatts. So we need to convert this 2.3 kilowatts to watts, since the SI unit of power is watts and not kilowatts. Remember, kilo here is simply 10 to the power 3, which is 1000. So for us to move from kilowatt to watts, we simply multiply this by 1000. So 2.3 times 1000, that gives me 2300 watts. So this is the power of the kettle, which simply means that this kettle consumes an energy of 2300 joules each second. So this is the meaning of this kettle having a power of 2300 watts. Now, the mass of water given to us in this case is 2.5 kilograms. And since the question says that it costs the temperature of 2.5 kilograms of water to increase by 50 degrees Celsius. So since the question uses for this word by, it shows that this 50 degrees Celsius is the change in temperature and not the final temperature of water. So this is the change in temperature, which is simply the final temperature of water minus the initial temperature of water. And we don't know the initial and the final temperatures of water, but now we know the change in the temperature of water, which is what? Delta theta. In this case is 50 degrees Celsius. And we've been given the specific heat capacity of water to be 4190 joules per kilogram per Kelvin. So now we've extracted the necessary information from the question. Now let us see how to solve this question based on the data that we've extracted from the question. So the question has asked us to determine for how long was the heating done. So now we are going to consider this relationship or this condition, which is the electrical energy that is supplied by the heater should be equal to the heat energy gained by water. So remember that energy is related to power, which is simply power is equal to energy divided by time. So from electric power is equal to what? Electrical energy divided by time. This implies that electrical energy is equal to the power times the time. Now remember that heat energy, or the heat supplied to any substance which is pure, is always equal to the mass of that substance times its specific heat capacity times its change in temperature. So for water, this is the heat energy that water is going to gain. Then for the domestic kettle, this is the electrical energy that it is going to supply to water. So this implies that E is equal to Q. E is equal to Q, which is the electrical energy supplied by the kettle is equal to the heat energy gained by water. So this implies PT is equal to MCW delta theta. Permit me to demarcate the board. So remember that we are asked to determine for how long was the heating done, which is the time. So we just need to make T the subject of this equation, and for us to do that, we simply divide both sides by P, which is the power. So this shows that the time is equal to mcw beta theta divided by r. This is equal to, the mass of water is 2.5 times specific heat capacity of water, which is 4190, times the change in temperature of water, which is 50. All this divided by the R, which is 2300 watts. So this shows that our T in this case would be 22.7. So this shows that our T in this case would be 227.7 seconds. If we divide by 60 for us to convert from seconds to minutes, this will give our T, which is the time, to be 30.8 minutes. So this is the time that the heater needs to operate for, so that it would be able to raise the temperature of 2.5 kilograms of water by 50 degrees Celsius. So this is how you go about answering this question. And if you loved this video, please help me and share so that I can get to many students as possible. And if this is your first time coming across any of my videos, please do not hesitate to either subscribe or follow me, so that whenever I upload videos like this one, you will be notified. And thank you for watching. Stay blessed.